In this question, the barrier potential of a PN junction depends on a parameter A is type of semiconductor material, parameter B is amount of doping, and parameter C is temperature. So the question is asked, the barrier potential of a PN junction depends on which of these parameters. Now the options for the answers are, the first option says that parameter A and B are correct. The second option says that it depends only on parameter B. The third option says that it depends on parameter B and C only. And fourth option says that it depends on parameter A, B, and C. Okay, now here in this question, we should first remember what is a barrier potential. So if you see a PN junction, so here you can see a PN junction. So this is a P-type material shown here and N-type material. So P-type material will have holes as majority charge carriers. So this is P-type material, which will have holes as majority charge carriers, and N-type material will have electrons as majority charge carriers. And when we join the PN junction, the P-type material holes will cross over to the N-type region, and N-type region electrons will cross over to P-type region. And as these majority charge carriers move, there is accumulation of immobile ions at the junction. So here you can see the negative ions, and here you can see the positive ions, and therefore we have an electric potential at the junction, and this electric potential is called as barrier potential. Now, what are the parameters on which this barrier potential are depending? So the first parameter what we have seen is the semiconducting material. So if you see semiconductor material, the material called as silicon will have a barrier potential of 0.7 volt, and the material called as germanium will have a barrier potential of 0.3 volt. So definitely this electric potential, what is called as barrier potential here, will depend on the type of material, whether it is silicon or germanium. So the first parameter is on which the electric potential depends. The barrier potential depends. The second parameter says doping. Now doping is one which is adding of impurity to the semiconductor, to the pure semiconductor, to change its conductivity. So it is a process of adding impurity to increase the conductivity, to increase the majority charge carriers in a P-type or N-type material. So if you increase the majority charge carriers, automatically the barrier potential is going to increase. So the second parameter also is one on which the barrier potential depends. And the third parameter is temperature. So temperature is one which we can see that if you increase the temperature, there will be change in minority charge carriers. That is, for P-type material, electrons are minority charge carriers, and for N-type semiconductor, holes are minority charge carriers. So the minority charge carriers, the number of minority charge carriers will change because of breaking of covalent bonds, and therefore temperature also is one parameter on which the barrier potential depends. So out of the three parameters shown in the question, whether it depends on semiconducting material, or it depends on doping, or it depends on temperature, so we can say that the barrier potential depends on all the three parameters. So here you can see the explanation. Barrier potential depends upon, number one, materials used to make PN junction. That is, for silicon it is 0.7 volt, and for germanium it is 0.3 volt at room temperature. It also depends upon amount of doping done, because the amount of doping will decide the amount of majority charge carriers in the junction. It also depends on temperature, because increase in temperature will change the number of minority charge carriers. So here in this option you can see option 4, that is the parameter A, B, and C all stands true. So the barrier potential depends, the barrier potential of a PN junction depends upon all these three parameters. So option 4 is the correct answer.